eyes with me. Follow. Okay. The one thing's going to be different today. Ollie, would you read this out loud, please?
Can supervise how equations and one variable terms on both sides.
Okay, what's different? Can anybody pick out what's different than what we've been doing the last couple of days with this learning goal? Because it actually has changed a little bit. What's the difference here? You can pick it out, Blake?
One variable.
Okay, no, weren't the equations that you solved for today just in one variable? Was there more than one variable in an equation? Was there? If it had x's in it, was it just x's? If it had c's in it, was it just c's? Okay, so that's not it. We've been solving equations in one variable. We've been doing that for a while. So that isn't it. Anybody else think they know? What else has been true about the ones that we've been solving up, this last couple of days? One variable is all that's in them, but then there's been variables what? On both sides. Well, that's been there already with variable terms on both sides. And we've been solving them. So what appears to be different? Simplify. Today we are going to have to simplify first before we can solve. And remember, when we simplify, what don't we do when we're simplifying that we do when we're solving? Anybody remember that? So what are the two simplifying steps? Anybody remember? One starts with a D. Distributive property, thank you, Andrea. And what's the other simplifying that we learned? Combining like terms. So we're going to look for simplifying first today. And when we simplify, let's recall, when we simplify, what do we not do when we're simplifying that we do when we're solving? When we solve, what do you have to do? If you're going to undo addition, you undo it with subtraction, and you do it on both sides. When you simplify, do you have to do it on both sides? Do you have to do the same thing on both sides? No. If you have some like terms to combine on one side, you may not have some on the other side. You're only going to do it on that side. You don't have to do the same thing. So we have to, that's the thing we're going to have to make sure that we keep straight today. So let's put up here that we are doing lesson 1.5, notes 2. Let's have a title for them. So you should be on a new page in your notebooks. Lesson 1.5, notes 2. And today we are going to simplify. That's the new thing that we have to do. And then we're going to use all the same skills that we've been doing the last couple of days. Then we're going to go about solving it. So today your first focus needs to be simplifying and then go about the solving process that you already know. So let's do some practice here. Number 1, our first practice problem. I want you to write down the following equation carefully. 10m minus 12 plus 2m, that's all on one side. And on the other side is Lone Ranger 6m. So today we're going to learn that we sometimes have to do something else before we start solving. First of all, I recognize that there's variable terms kind of like all over the place. They're on both sides. So that says to me, you know what? I know what I have to do when they're on both sides, but before I do that, because I got some m's, 2 sets of m's on this side, I'm going to have to do something else before that. Blake?
Do we have to add opposites here?
Do we have to add opposites here right now? I would say for those of you, I would say yes. Because I saw this happening yesterday, or day before yesterday again. When we don't, the subtraction signs get left behind. So we do, so we're going to rename this first of all. We have one subtraction in it to deal with, so we're going to rename it 10m plus what? Negative 12. And then plus our 2m equals 6m. The reason we do that is we don't have to worry about them leaving something behind, and that's what ends up happening. So, what do you suggest we can do here? Should we just go right to work solving it?
You can subtract the 2m from the 10m.
Okay, subtract the 2m from the 10m. You guys want to agree with that? Should we do that? Seth doesn't want to. Okay, Seth, do you have a different idea? So combine them and then it becomes 12m? So if we subtract 2m, what would happen, Adam? What do you think it's going to be?
You would minus the. Well, actually, wouldn't you subtract the 2m from the 6m first?
Okay.
If you wanted to, and then if you then add the. Oh, actually, no. You would subtract the 2m from the 10m.
You would subtract the 2m from the 10.
Yeah, and then that would equal 8.
Now, actually, I'm kind of happy that Adam said that because Seth has a different idea, and I want us to see which one should we go with. And here's what I see on papers a lot. Don't necessarily write this down. Just follow along with me. Eyes up here. Here's what I see on papers a lot. This 2m, you're trying to get it, put together maybe with the 10m. So here's what you think you can do. Can we do that? Think of this as an equation. We just did the same thing twice on the same side. Would this equation stay balanced? No. So kind of like saying we have, two people on a teeter-totter of equal weight. We take, and, one of the persons was lighter weight to begin with, so they had to stick a couple of things in their pocket, equal weights in each pocket so that they would be the same weight as the other person. So we have this 140 pound person on one end of the teeter-totter, and we have this person who was actually only 120 pounds, but they wanted to balance the teeter-totter. So the person who was 120 pounds stuck a 10 pound weight in this pocket, and they stuck a 10 pound weight in this pocket, and now 10 plus their weight of 120 is 140, and now they weigh the same as that person on the other side of the teeter-totter. Okay? Well, if we take those two weights away from that person on this side, and we take, a weight away and another weight away on the same side, is that equation going to stay balanced? Is that person, now they're going to weigh 120 pounds, aren't they? And the other person weighs 140. Is that equation going to stay balanced? Is that teeter-totter going to stay balanced? No, it's not. We can't do the same thing twice on the same side of the equation. So we can't do this because this would become 8m. I'll agree with you, Adam. That is what would happen, but this is not something we can do. We can't really do this. So I think we're going to have to explore Seth's idea where Seth says, add them together because they're on the same side. They're on the same side. Bring them together. Okay, so 10m plus 2m is 12m. That's what we can do. And then plus negative 12 equals 6m. What do we call this negative 12? What's my line for it? A tag along. Yeah, it's got to come along. Don't forget it. It's tagging along. Okay. So this is called simplifying right here. We just did some simplifying. I don't have any room over there, so I'm going to put it here. Would you put that in your notes, either in front of it or behind it, that you were simplifying in this step? Is there any other simplifying we need to do before we move on to solving? So what you're looking for is on the left side, can you combine any more terms? How do you feel? Anybody think we can combine any more terms on the left side? How about the right side? Does it have anything to be combined with? No. No, it's on the sides. We're just paying attention to the sides. Hey, you over there, can you have anything done to you? 12m plus negative 12? No. Hey, you over there, 6m, can you have anything done to you? No. Now we're ready to solve. So now we're ready to apply all those rules we've been following. We have one side that does not have a constant. What do we do when we have a side that doesn't have a constant?
You add 1.
We can't add a constant in there. We don't want to do that. We could. What constant could we add? That wouldn't change the value. No, you can't add 1 and not change the value. If I have $5 and you give me $1, I will still have $5.
0.
0. But we're not gonna put a plus 0 there, we're gonna say, you know what? Since that side doesn't have a constant, I'm gonna concentrate on this side. I'm gonna get rid of the variable term on this side, so I'm going to subtract 12m.
Negative 12
Negative 12 equals
equals 6.
negative, so if I change this to add the opposite, I have a positive 6 plus a negative 12. That ends up at negative 6 on the number line. Those are m's.
Divide both sides by negative 6.
And now we're going to do what, Blake?
Divide both sides by negative 6.
Divide both sides by negative 6. Why negative 6? I don't want to divide by a negative. I like positives better. Why do I have to divide by a negative 6? No, that's not the variable. Yeah? Because that's what the variable is being multiplied by. We have to look at what it's being multiplied by. And you know why am I making such a big deal of that? I see this happening too. The variable is getting multiplied by a negative number, but yet you're dividing by a positive number. Is that going to undo it? No. So we have to make sure we're dividing by the correct number or showing the signs properly. So now we have m alone, and what's a negative divided by a negative? Positive. How many 6s in 12? 2. Is 2 equals m the same as m equals 2? Yeah.
We're gonna show all this on our homework.
You sorry? Okay.
I'm sorry.
Anybody have any questions other than, do we have to show all this on our homework? I already answered that one, yes. Any others? Okay, write this problem down now then. You ready? Number 2. Now you know how much work you have to show, so you know how much space you need, right? 7x equals 5, take away x, take away 21. First thing I see is subtraction. So I'm going to rewrite it how? Who wants to share with us how we're going to rewrite this? Sam. Sam. Thank you, Sam, for volunteering and doing it without your mouth moving. Okay, what's it going to look like?
7x equals 5 plus negative 1x plus negative 21.
Good job. There we go. There's its new name. It's going to be more user-friendly this way. I like user-friendly. Now we're going to say to ourselves, oh, wait a minute. Now, there's kind of a long side over there on the right side. Maybe there's something I can do. What can I do on that right side? Can I simplify this? What do you think, Preston? I don't want you to just sit there and wait for us to do it for you, so help me. Come on.
Add 1x.
I'm looking at this long side over here and I'm saying, you know what, it's long, there must be something I can do with it.
Oh, put the 5 and 21 together.
Yeah, I can put the 5 and the negative 21 together because they are like terms. They are both, what's that name for them? Constants. Okay, so now I have 7x equals, what's 5 plus negative 21?
Negative 16.
Negative 16.
Does it matter if I put the x first and the negative?
You want these guys to trade places?
Oh, that's just
They
the way I
can't.
did it because it was there first.
Yeah, it's because there's addition in between them. Certainly we can do that. Okay. So what Blake was asking is, can we bring the tag along down first instead? So I think this is what Blake is saying he did. Oopsie, I'm not going to do it.
I just did 7x.
You did negative 1x plus negative 16 like that?
Yeah.
Yeah, that works too. So or, we don't have to do both, just one or the other, okay? Any more simplifying we can do? Because that's called simplifying, right? This is simplifying right here. We have like terms on the same side so we can bring them together. We are simplifying. And now we're ready to solve, aren't we? Okay, it's going to be our first move here. Okay, why add 1x?
Because you want to get the variable. You want just the negative 16 alone.
Yeah, Yeah, because there's no constant over here, is there? So since there's no constant on this side, we're gonna get these guys moved over there with them. We're gonna add 1x because the opposite of -1 is +1. So we'll add 1x to both sides. 7x plus 1x classes, and -16 doesn't have anything to do but come on down. What are we gonna divide by?
8.
8. So 8x is gonna get divided by 8, and -16 is gonna get divided by 8.
X equals
And the solution is, okay. Because why? Why is it a negative? Isaiah, why is it a negative? Yeah, because we're making a negative divided by a positive. When they are different signs, our answer is a negative, doesn't it? Okay. Okay, I'm going to put another one up there, and I'm going to let you go after solving this one all by yourself, and we'll see how it goes. Are you ready? Yeah. You can do this? Okay. Number 3. And Mrs. Creviston, Mr. Ramble, and Mrs. Legrand all are going to walk around to make sure that we're just going to help guide you in case something's not going very well. We'll be like, I would suggest, go, this is your baby, do it. That's my baby? That's your baby. Go. It can happen. Good first. Samuel. No. Okay, first of all. Is this, so this is already added to the other? Okay, so. What should we do next? There you go, I like that.
6x.
You didn't put it as it started, and then you should put it as it started probably. Okay. So you might want to change something there.
Yeah, I just have. I'm just so used to the regular way.
So go ahead. You have a great answer, but I was told you can't. No, thank you.
If we can see it. No.
Well, which side? So you're using 2x over here. So minus 12. He does that? Don't put it in. You take the paper, I'm gonna guess this. You can take this with you. So here, that just set right here is where I'm. That's what I have written up here. Okay, that's good. See if we agree that with. What's that? Okay?
We got 2 or negatives.
Well, what, because you just trying to
Because
decide
I
which one
thought-
you like it?
That's all you need. That's a negative.
Yeah, it's just a negative. You can't bring down the positive. Oh, use your fingers of the pen, it skips, yeah. See, like what's happening, how it's skipping. Just. What, let me, oh. You wanna do what? Okay, so you want to,
I have my.
so what's gonna be the result after this? I wanna see what the result is after this step, okay? And then you can move on to your subtracting or whatever you're gonna do next. Got an answer? What's your that, Adam? No, that is, you're just letting that go right to your question. What's the sugar? And how many sugars are there in an egg? Oh. Would be a little bit earlier. I don't know, let's see if that's what's up. Okay, we'll check it out. He said he's gonna go about it differently than you guys do, but we'll just, first of all, we'll just compare answers, and then we're gonna talk about process videos, okay? Okay. Okay, is this a, what's going on here? I'm kind of confused right here. That's a dividing, and do we divide by the x? Really? Okay, so let's do this. Let's take this and erase this part, right? This is the part we want to erase. Okay, and then it goes over to this answer. Okay. Okay, how many of us agree with Seth? He says the solution to this one is x equals -4. Got a few in agreement. Okay, now, I want to note something that Seth did that we have not been doing, but we're going to see if he still gets the same, if he does have the right answer, okay? What did Seth do that's probably different? This is it right here. What did Seth do that's different than your first step once you started solving? Find the solving part. Was your first step adding 3 to both sides? Anybody else in here, was that their first step? No. Because that isn't how we've been doing it. Is it wrong? No, it's not wrong. It's not wrong. It's just, this is how we've been doing it. We've been dealing with the fact that there's variable terms on both sides first, haven't we? So somebody else tell me what was their first step. Instead of adding 3 to both sides, what was your first solving step?
Changing subtraction.
No, solving step, and you listen to my question. What was the first thing you did on both sides of the equation, Blake?
I subtracted 5.
You subtracted 5 from both sides. So that's another first step that could have been made. Is that the way we've been doing it? Have we been moving the constants first? No, we haven't. But I bet it works. Holly?
I subtracted 2 from 6.
You subtracted 2. Oh, you put these guys together, you mean?
Yeah.
And that became this. I'm asking what was your first step right here? After we get to this is now we're ready to solve. So what was your first step after that?
I subtracted 5 to both sides.
Okay, you subtracted 5 to both sides also. That's what, who else did that? That was Adam.
He did not.
Okay. You didn't really?
Did not.
Okay. What did you really do then, Adam?
Added 6x.
Minus.
What did you minus?
2x.
2x, okay. Yeah. You guys have a little bit of trouble figuring out your words, don't you? Huh? Where I'm talking about? I'm sorry. Okay, so once we have the equation simplified, we have this. So what we want to do is, now we can start doing the same thing to both sides. Here's what Adam did. He subtracted 2x from both sides. Now, is that okay to do? How many of the rest of you, this is your first move when you're starting to solve? Subtracting 2x from both sides. Okay, that was a good first move. And then we said, Seth here added 3. Anybody else? No, I don't think anybody else did that. But then I had some people that said that they subtracted, was that you, Holly? Subtracted 5 from both sides?
Yeah.
Okay, so there's a variety of ways to go about this, okay? There's a variety of ways to go about it. But here's what remember I said to you, I'm afraid is going to happen is if we move the constants first, everything's going to end up on one side, and you're going to just move your equal sign however you want to move it. So we have to just make sure that we're following it down on each side and bringing that equal sign down with it. So I would suggest this would have been a good way to do it. This would have been a good first move to make. This would have been the first move I would have made. Those of you who did it this way, did you get x equals -4? Okay? What's this become? 2x plus 5 equals -3. These guys cancel. What's our next move in this one? What do? Undo adding 5, we subtract 5. -3 subtract 5. That's -8. It's the same as adding a -5, so this becomes, these guys are gone, it gets 2x equals -8. Look at here. Now we're going to divide by 2, and -8 divided by 2 becomes x equals, negative divided by a positive is a negative, 8 divided by 2 is 4. Get the same answer. So, my point being, the reason I let you guys kind of just go off on your own is also this. There is more than one way to do it correctly, to go about. We don't all have to follow exactly the same steps to doing it, but what you have to do is you have to make sure you're doing steps that you can really do. You have to be making sure that you follow a process that makes sense, and we all, in the end up with the same answer. So if you did not end up with x equals -4 during homework time, an adult in here, we now have 4 of us, should help you out. Okay? We're going to try one more together. We're going to practice one more together before we move on. Okay, number 4. We have x take away 1 equal to -2x minus 3x plus 3. We will change subtraction to add the opposite. Okay, everybody do that. Rename this as an addition problem. Everybody do it on their own papers. Rename it as an addition problem. And by the way, if you also want to slip a 1 in front of this x here, feel free. Okay, now, I already know that on some papers, here's what's going to happen. Some people are just going to go right to work solving right away. And they might get away with it. You know, they might end up with the right answer in the end. But they're actually, sometimes it's going to end up confusing them more than it's going to help them. So we're going to keep with the same process of our thought has to be, can we do any simplifying? So look on the left side of this equation. Can we simplify it?
Yeah.
With 1x plus -1, are they like terms? No. So we can't simplify the left side, can we? How about the right side?
Yeah.
Okay, what can be done on the right side?
-2x and 3x.
Okay, these guys can be put together, can't they? So this side is going to stay like it is because they're not like terms. They can't be grouped together. -2x plus -3x. -5x. Bring along the tag along 3. And now we say, can those guys be put together? Are they like terms? No. Is it ready to solve then? We've just simplified. Is it ready to solve? In other words, what we do now, we do to both sides. I'm going to suggest that a lot of you should probably start doing this also. Let's make that line bring down from the equal side so it kind of separates the sides. Leah? -3, okay, that is a move. That's a move we could make. Let's just go through all the options of things we could do. We can subtract 3 from both sides. Seth? We could add 1 to both sides because that would undo this one. What's another thing we could do? What's another option? Another first option. We've heard that we can subtract 3 from both sides. That would get that guy take care of that. We've heard that we can add 1 to both sides because that would take care of that. Seth?
Add 5x to -5
Okay, so we could add 5x to both sides. That would take care of this. We could add 5x to both sides. Or last but not least, there's a fourth option. What's another thing we could start with? We could subtract 1x from both sides to take care of that. We have 4 options of things to do. So I can't say that, if you don't do it my way, the same way I do it up here, yours is wrong. But whatever way you choose, it better lead you to the right answer, okay? Legitimately. So I like the option of adding 5x to both sides. I always like to deal with the variable terms first. Let's take care of them. They both have constants with their variable terms, so it doesn't matter which side we deal with them on. 1x plus 5x,
6x.
what's left on the other side?
3.
3. Now what would be
You would
the
add,
smartest move we could make?
you would add 1.
We could add 1 to both sides. Add 1. That undoes that plus a negative 1. And now we have 6x by itself. These guys take care of each other. 3 plus 1 is 4. Now what are we going to do?
You divide the 6.
Divide what?
Both
sides.
There you go. Way to stay on my side. 6x divided by 6 and 4 divided by 6. Both sides get divided by 6. And then you say to yourself, oh, no, I must have done something wrong.
I always think that, but I'm surprised you're right.
It's okay, though. It's okay. Even though 6 doesn't go into 4, we don't care. It's okay. What are we going to do? Are we going to take out our calculators now? No, because this would be when you take 4 divided by 6 on your calculator, anybody know what it's going to do? It's going to be 0.6666666, and all of a sudden it's going to throw this 7 in there. Is that what you're going to write on your paper? 0.6666667? No. That's not a nice decimal. We don't get to write them when they're not nice decimals. So instead we say, well, just leave it as a fraction. But then that can be simplified to x equals 2/3, which is the repeating decimal 6. That's how we will give our answer when it doesn't divide out nicely. Okay? Yes, ma'am. Okay, what'd you do? You subtracted 3 from both sides instead first? Okay? We did say that was a move we could make, but I asked us to do this one together, but okay, go ahead. So after you subtracted 3 from both sides, then what? Okay, I'll look at your paper because we're taking up people's homework time here. Okay, anybody have any questions?